Hello students, welcome to RD Chemistry. In this video, I'm going to solve some model question for coming NEET examination. Question number 1. Which of the property of white phosphorus is common to red phosphorus? That means which is true for both white and red phosphorus. It gives vapors on heating. It is correct for both white phosphorus as well as the red phosphorus. Second statement, it reacts with the hot caustic soda solution to give phosphine. Only white phosphorus P4 reacts with the sodium hydroxide and water sodium hydroxide solution to give phosphine PH3 poisonous gas and sodium hypophosphite, whereas the red phosphorus will not give. Third one, it shows chemiluminescence. Chemiluminescence means it is glowing in the dark. It glows in the dark. Only the white phosphorus glows in the dark, not the red phosphorus. It is soluble in carbon disulfide. Only the white phosphorus P4 is soluble and red phosphorus is insoluble in carbon disulfide. Therefore, only the one option which is matching the both the phosphorus white and the red phosphorus. Answer is option number A. Let's see question number 2. A crystal is made up of particles A and B. A form the FCC. B occupies all the octahedral voids. If all the particles along the plane shown in the figure are removed, then the formula of the crystal would be. Now, A is there in the FCC ladder. That means FCC means corner particles, 8 corner particle contribution is 1 by 8. Correct? Right? Plus faces. There are 6 faces into contribution is 1 by 2. Total there will be 4 particles. Fine. And B occupies all the octahedral void. Where will be the octahedral void? Octahedral voids are there in the edges. Plus there on the one body center. These are location of the octahedral void. So B will be on 12 edges are there into contribution each edge is 1 by 4. Correct? Plus body center contribution is 1 into 1 it is. Okay? So it is a 4 particle and 4 particles. But the particle along the plane are removed. See this plane. Okay? Corner to corner, corner to corner. 4 corner particles are going. Then 2 face particles are going. Correct? And this edge has got one octahedral void and one octahedral void. Correct? So we'll have to deduct now. Corner particles are 4 are going, 4 into contribution each corner particle is 1 by 8. Okay? Plus face particles are 2 in number, they are going from here. So it is 2 into 1 by 2. Okay? So you have to count this one. Similarly, from here, minus, we have got the edges. Edges 2 are going. If the 2 edges are going, it is 2 into 1 by 4. Correct? Plus 1 body center is going. So 1. Okay? So total this will be equal to 5 by 2 and 5 by 2. You have to solve carefully. So it will be like A 5 by 2 and B 5 by 2, which is equal to 1:1 AB type only. Therefore answer is option number A. Clear? Question number 3. In which of the following pairs first has a higher melting point than the second? Let is the first one. This is the ether, first one the ether, second the alcohol. Alcohols have got more boiling point. So first one doesn't have the higher melting point. So wrong answer. Second option. Both are alkanes. Correct? Both are alkane. In the first case 1, 2, 3, 4 carbon. In the second case 1, 2, 3 carbon. That means larger the number of carbon atom, more is the molecular mass. The first one has got higher melting point. Correct. So second should be the answer. We'll go for the remaining. Now, in the option number 3, first one is the alkane and second is the alcohol. Alcohols have got more boiling point. Second one is the higher boiling point, melting point. Next one, D option. First one is the alkane, second one is the haloalkane. Haloalkanes have got higher melting point, boiling point due to dipole-dipole interaction. Therefore, option number A, B is the answer. Okay. So first compound has the higher melting point than the second one. Question number 4. In the following reaction, ethyl chloride reacts to the potassium nitrate in the DMF solvent. A is the major product. So ethyl chloride CH3 CH2Cl. Potassium nitrate is the ionic compound K plus O minus N double bond O. Nucleophilic center is oxygen, attack the carbon atom and the Cl goes off. Therefore, we'll get CH3 CH2O N double bond O. We get ethyl nitride compound. So, which bond is absent in here? Carbon nitrogen we can't see. Direct bond is not there. Absent. Okay. CO bond is there. Carbon oxygen bond is there. Carbon hydrogen bonds are there. CH bonds are carbon hydrogen bond. CC. Carbon carbon bond is there. So ethyl group is there. So the answer is option number A. Carbon nitrogen bond is absent here. Clear? So A is the answer. Question number 5. Which of the following amide does not undergo Hofmann bromide degradation? For Hofmann bromide degradation, we should have the amide of the type RCONH2. It reacts the bromine and alkali, wherein CO is lost, we'll get RNH2. Primary amine we are going to get. Now, propionamide with the 3 carbon atom should be CH3, CH2, CONH2. Correct? This can answer. Second option, N-methyl, methyl is CH3, methyl, butanamide. Okay. So, NH2 is not there, free NH2 is not there. It is a derivative of the amide is there. So, carbon number 1, carbon number 2, carbon number 3, carbon number 4. So, CO is here. Okay. So, there is no free NH2. So, second one cannot undergo this reaction. Butanamide with a 4 carbon atom, 3 and 4. So, C double bond O NH2 is here, right? This is a butanamide. This can answer. N, N dimethyl butanamide CH3, CH2, CH2, C double bond O and NH2 is a butanamide. N, N dimethyl butanamide is this one. There is no free NH2. So, second one, fourth compound cannot undergo Hofmann bromide degradation. The answer is option number D, 2 and 4 compound, right? Question number 6. 0.395 gram of organic compound by Carius method for the estimation of sulfur gave 0.582 barium sulfate. Percentage of sulfur you have to calculate. So what is done is sulfur present in the organic compound has been converted into barium sulfate. Okay, barium sulfate. Now, only one sulfur atom is there. So that means 32 grams of sulfurs are present. Barium atomic mass is 137. Sulfur is 32. Sulfur is 32. Oxygen is 16 into 4 is 64. This will be giving 233. So percentage of sulfur is equal to, if I take 233 grams of barium sulfate, in that 32 grams of sulfur is present into mass of the barium sulfate that is formed in the reaction divided by mass of the organic compound taken into 100%. So this is equal to 32 divided by 233 into barium sulfate 0.582 grams divided by the organic compound 0.395 into 100%. This will give approximately 20.2 is the answer. Okay. So the answer is option number A. Clear? Seventh question. In the compound carbon, hydrogen, nitrogen are present 9:1:3.5 by weight. If the molar mass of the compound is 108, molecular formula. So we have got carbon, hydrogen and then we have got nitrogen, correct? So we have got first one 9:1:3.5 by weight, like it is in terms of grams. Okay, ratio. Then what is the next one? We have to calculate number of moles. 9 divided by 12 you have to do. Atom mass of carbon is 12. 1 divided by atom mass of hydrogen is 1. Then 3.5 divided by atom mass of nitrogen is 14 is equal to, we'll get approximately 0.75 here. This is equal to 1. This is approximately equal to 0.25 ಬರುತ್ತೆ ಆಯ್ತಾ. Now take the simple whole number ratio, correct? This is the 0.25, 1.00, 0.75. Like you convert into percentage type. 75, 100, 25. So 1 is to 3 is to 4 ratio. Clear? So the C1, H, C3, H1 and we'll get H4 and N1 will get, correct? Now we calculate the empirical mass. Empirical mass, carbon 12 into 3 is 36. Hydrogens 1 into 4 is equal to 4. Nitrogen 1 into 14 is equal to 14. This gives 54. Then calculate, okay, molecular formula should be empirical formula C3H4 and N1s, correct? So therefore first you need to multiply by N times. So N need to calculate. N is equal to molar mass 108 divided by empirical mass 54. This will be equal to 2. Therefore molecular formula is equal to multiply by 2 C6H8 N2. Okay. So therefore answer is option number C. Okay. Question number 8. Bond enthalpy of the hydrogen molecule is given. That of the nitrogen is given. And calculate the bond enthalpy of the nitrogen-hydrogen bond in the ammonia. And delta HF naught for the formation ammonia is given. Suppose right N2 plus 3 moles of hydrogen gives 2 moles of the ammonia. But they mentioned formation ammonia should be ammonia is always 1 mole of the ammonia should be formed. So therefore, what I should do is I should divide by 2. So half mole of the nitrogen plus 3 by 2 of the hydrogen. Correct? Now to write down delta H of the reaction is equal to, in terms of bond enthalpy of the reactant minus bond enthalpy of the products, which is equal to, now nitrogen half the mole we have got, half into bond energy of nitrogen triple bond, got it, plus 3 by 2 the hydrogen enthalpy, correct, minus ammonia. In ammonia, how many bonds are there? NH bonds are there? 3 numbers. So count is 3. So it is a 3 into NH bonds, correct? And the delta H formation ammonia is given already. So this number is supposed to be minus 46.0 kilojoules. So minus 46.0 is equal to half into nitrogen bond 941 energy plus 3 by 2. That of the hydrogen is 436, right? Minus 3 into NH bond strength we have need to calculate. Okay. So therefore we'll be, so on calculation 3 moles of the NH bonds will be equal to, will be getting answer 1170.6 calculation. Therefore NH single bond energy is equal to 1170.6 divided by 3. This will give around 390, approximately 390 it will come. Okay. So therefore answer is option number C. Clear? Question number 9. In which of the following pairs both species have the similar geometry? Okay. To have similar geometry, hybridization should be same. Correct? Hybrid should be same. CH4, you know that is a sp3 hybridized. BF3, it is a sp2 hybridized. Suppose you don't know how to find out, then use the formula hybridized H is equal to half into number of electrons in the number of electron present in the valence electron present in the central metal atom plus number of monovalent atom minus charge on that particular species. You can make use of this one. So I'll skip that one. I'll write directly. Ammonia is a sp3 hybridized. BH3 is a sp2 hybridized. Carbonate is a sp2 hybridized, whereas sulfite is a sp3 hybridized because sulfur has got one lone pair, oxygen, two negative charges are there, it's a double bond. Okay. Sulfate is a sp3 hybridized, and here chlorate is also sp3 hybridized. Okay. Therefore answer is option number D. Clear? Question number 10. An element with the atomic mass 300 crystallizes in the simple cube. If the density is given, what is the radius of the element? They are given simple cube. For the simple cube, radius 2 times the radius is equal to edge length A. A is equal to R. So what we need to calculate is we have calculated the edge length A. Density formula I got Zm divided by A cube Na, correct? Therefore, A cube is equal to Zm divided by D into Na, correct? Now, for the simple cube, Z is equal to 1. Number of particle per unit cell is equal to 1, correct? So, 1 into 300 divided by density 9.5 into Avogadro number approximately 6 into 10 power 23. And this will give rise to answer, or the approximate answer, this will give rise to 52.4 into 10 power minus 24 in terms of centimeter cube. Now we have to find out A. A is equal to, slowly need to solve this one. Now 10 power minus 24, cube root will be 10 power minus 8, centimeter cube becomes centimeter. Now carefully solve. 3 cube is equal to 27, 4 cube is equal to 64. Answer should be in between 3 and 4. So you can try for 3.5 cube, okay, but that will give approximately 43. So now when we look at the answers are not very close to each other. I'll not take 3.5 as such. I'll go for like 3.7. May not be exact. Okay, right? You can try. You can take 3.7, 3.6. We'll try. It'll take time. Okay. Now we have got A is equal to R. Therefore, R is equal to 3.7 into 10 power minus 8 divided by 2. So this gives approximately 1.7 into 10 power minus 8 gives. Correct? So the answer is option number A. First one is the answer. Clear? Students, if you like this video, please share, subscribe and support me. Thank you for watching. May God bless you all. Good luck for your coming examination. Study well. Take care. Have a nice day.